And welcome back for our third and final part of this lesson. Again, this is going to be lesson one, section 4.1 on angles and their measure. So we are going to explore arc length of a sector. So to begin with, we can look at, we have a circle with a radius, and it is intercepted by a central angle. Now, a central angle means that this is an angle that is has its vertex at the origin. And the formula for the arc length is r, the radius, times theta. Theta is the measure of the angle in radians. So, when we are looking at this, in order to find the length of an arc that is intercepted by this angle, we can say that S is equal to 14 times sorry y'all, this is, there we go, times pi over 12. Okay, so if we have 14 times pi divided by 12, and we want to round this to the nearest tenth of a unit, this would be 3.7 meters. It is important to have the units included. Okay. Now, in example B, we have our theta is 20 degrees. But let's recall that when we have something in degrees and we want to calculate the arc length, we need that in radians. So the first thing that we're going to have to do is convert degrees to radians. Okay. And remember, if we're going to radians, we want the radians on top. So we're going to multiply with radians on top. Okay. So we're going to start out and say, well, 20 times pi over 180, which is going to give us pi over 9. Okay. And now we can say that S is equal to 2 times pi over 9. And again, pulling out our calculator, 2 times pi, and then dividing that by 9, and rounding to the nearest tenth, we get 0.7 feet. Okay? All right. We're not going to mess with the formula or calculating that distance there with the globe. What we do want to look at, though, is angular speed. Okay, and then we're going to get into area of a sector. So angular speed, this is the speed that the wheel is spinning. So we look at that in revolutions. Um, and in order to calculate the angular speed, we use the formula. This is actually lowercase omega is equal to theta over t, where t is time, and theta is in radians. Okay. So if we have a wheel that has a diameter of 1 foot and it spins at a rate of 40 RPM, okay, then we need to consider, to find the angular speed, we kind of need to back up here, okay? So the first thing that we need to consider is that when we have our angular speed of 40, okay, that is equal to the radius times this lowercase omega, okay? Or 40 is equal to 1 times omega, which is going to tell us that omega is equal to 40. Okay? Now, when we're thinking about how fast does it spin in feet per minute, okay? This is where we're looking at we have the angular speed of 40 and multiply that by the 1 foot, okay? Which gives us that it's the linear speed is 40 feet per minute. And I will say we're not going to do a whole lot with linear and angular speed. I just wanted to kind of expose you all to that, but not a super important concept. What is more important, though, is the area of a sector. Okay, so we have the formula for the area of a sector here. Area is equal to 1/2 times radius squared times theta, where theta is the central angle in radians. Okay. So our example here tells us that we have a radius of 12 feet. We have a central angle of 135 degrees. Okay. And we're looking for the area of our sector. Well, recall, we need that angle measure to be in radians. So since we're going from degrees to radians, okay, oops, that means that we are going to multiply with the radians on top, okay? So we're going to start out and say, okay, so what is 135 times pi over 180? So we can do 135 times pi divided by 180. We do not want to round this very much right now, okay? So this gives us approximately, I'm going to take it out 3 decimal points, 2.356, okay? Because my rule of thumb is whatever you're being told to round to at the end, as you're computing things, you want to keep it a minimum of 2 decimal places longer than what you're going to round at the end. So now we have our 2.356 that we are going to multiply by 12 squared and multiply that by 1/2 because we're going to plug it into our area formula. Okay, so we have our 2.356 times 12 squared times 1/2. And then we want to round that to the nearest tenth. And we get that that is 169.6 feet squared.